Hello everyone, welcome back to the channel. A lot of you mentioned about Unsloth in the comments and today we'll get into it. This tutorial on fine-tuning the SQuAD dataset using Unsloth on Google Colab. We will walk through the entire process from data preprocessing to model fine-tuning using a practical hands-on example. If you wonder what is the process look like in the flowchart, check out my previous video. In this tutorial, we'll be working with the Stanford Question Answering Dataset SQuAD, a benchmark dataset for reading comprehension and question answering tasks. We'll use Unsloth, a powerful library that helps streamline working with large language models through parameter efficient fine-tuning methods like LoRA adapters. And of course, we'll run everything in Google Colab. So even if you don't have a powerful GPU at home, you can follow along easily. Let's get started. This is the code. It looks a little bit intimidating, but believe me, bear with me to the end. It's get easier than it looks. Alright, so first we do the installation. Very straightforward. And then we get into load the pre-trained LLM. In this tutorial, we'll be working with Stanford question answering. Later on, I'll show you how the dataset structure because the pre-processing is very important for the fine-tuning part. If we don't pre-process correctly, then the task, then later on when we ask the model to do the inference, it may not as the intention. So pre-processing for this. This is the benchmark dataset designed for machine reading comprehension and question answering tasks. We'll see later. Let's load the pre-trained language model using Unsloth library FastLanguageModel Class. So from Unsloth, we import FastLanguageModel, and then we also import torch. This is the math sequence length. This is the comment from Unsloth document. There's very clear, very detailed. For this D type, I choose none just to get the model to do the auto detection. If you want to do this or this, you need to have torch.float16 or torch.bfloat16. Alright, and then this one, I just want it to be true because I want to reduce the memory use 4-bit quantization. Usually it's like 16-bit, 32-bit, but this one reduce memory uses. It can be false, but we just want to make sure it's run fast, so true. These are the 4-bit pre-quantized model, like I say, is 4x faster than normal. So normal is like 16-bit, 32-bit. These are all of the model, and I'm using Llama for this fine-tuning. As you can see it here, rabbit under the from pre-train, having a model and tokenizer, having a model name, very straightforward. You can change this depending on what type of model you want to use. I use Llama, open source, free, max sequence length. This is here. You can choose any. And then the type as D type, and then we load in 4-bit. Get it run, very straightforward at this point. Next, we get to LoRA adapters. If you haven't heard about LoRA or haven't used LoRA before, LoRA adapters, which is low rank adaptation, are a method to use fine-tune the large language models in a more efficient way instead of updating all the parameters in a model. LoRA introduces small, trainable adapter modules into a model's architecture. We will be seeing it in the code. So now we add LoRA adapters, so we only need to update 1 to 10% of all the parameters, which make the fine-tuning process way faster. We also add the embedded tokens and an LM head to allow the model to learn out of the distribution data. This is recommended under Unsloth documents. Alright. This is a little bit overkill because I put all of the code into ChatGPT and I asked ChatGPT to generate the comment for me. So bear with me. It's easy. So we get the fast language model. And then we get the model, right? Then we got the R here is 128. Can choose any number. The suggested are 8, 16, 32, 64, 128. This number determine the trainable parameters in the low rank adapters. So the higher the number, the more of the capacity of the low ranks to learn the task specific. So for value like 8, 16, 32, 64, it can be a simpler task. 128 maybe get a little bit more complicated. So it depends on like what kind of fine tuning that you can choose a number. Here I'm just go with the higher one, like 128. And then here we have a target modules. These modules is where LoRa adapters should be applied. So we can see, like if you recall the multi-head attention mechanism, we have query, we have keyword, we have value, and we have output. So these we want where we, have a LoRa adapters just in there. And then this one we have gate, we have up, down is the additional projection layers used in gating mechanisms. And then we also wanted embedding tokens, LM head. This is for when we have like embedding and an output layer. So these are for like continual training if needed. So like pretty much you can pick and choose what kind of layer do you want to ingest the LoRa adapters, or you want to like apply the LoRa adapters. All right, LoRa alpha, what is it? It's a scaling factor applying to LoRa weight. So these are the factor just the influence of the LoRa adapters related to the original model weight. And then this drop out, do we want it to, drop out any raise for the LoRa adapters? The 0 mean no drop out applied. And it just like, this one is optimal for this configuration. Do we have any bias? Do we want to, add additional bias term introduced in here? Here it's just none. Use gradient checkpoint. Do we want to use it true or unsloth for a very long context scenario, which you'll see later in the dataset? The SQuAD dataset has context and then question and then answers. It is a technique to reduce memory by, trading compute for memory. This special unsloth setting here is an optimized mode that reportedly reduced the VRAM uses by 30%. So which is highly, highly recommended to have it here. A random state is like a seed in training to make the model reproducible. Use R's LoRa, active rank stabilized LoRa, enhanced version to improve the stability during the training. Just like, make sure that during the training, all of the parameters were stable, going from layer to layer. And in here, configure for loft key, another parameter efficient tuning technique. Here just set to none, which means it's not applied for this configuration. Now let's get to the data prep. This one is super, super, super important. It takes around like 70% of your workload. If you don't have the data pre-processing correctly, later on, the inference will be very difficult. So now we're using SQuAD dataset from Hugging Face. We'll only use 2,000 example just to, speed up the training a little bit. We also do trend test split. We have test sign 20%. Best practice, if you're familiar with machine learning, deep learning kind of process, these are like the best practice just to have some out of sample later to test how the model perform. This is But before pre-processing, I just want to show you that SQuAD had multiple components. As you can see it here, SQuAD has ID, title, context. This context is like where the model should look at and get the answers. And then we have question, and then we have answer. Within this answer, we have text, and we have answer start. So how do we want to use this? How do we want to make it into a clean and clear format for the fine-tuning? Do we need ID? Do we need title? Or we only need context, question, and answers? So that's how the next step here is a pre-processing function where we only take things that we need: context, question, and then answer. For the answer, we only need the text for the answer, so we don't really get into the second component. That's why this is just like a first component of that answers. And then we concat them all into this format. As you can see it here, this is SQuAD processed. So we have input, and then we have, within that input, we have context, we have question, and then we have a target text. And then after that, we have a formatting function here. This is super important. This part, remember to have this one into the end. It is end of text, or else your model will go on and on and on forever. So this one mapping everything into one nice format is called context. So we have context here, we have question here, and then we have answer here, which is kinda cool. And then now let's say we get into this one. Everything just need to put it in here. Let the models know that, all right, we have a trend. This is our trend data set. Where the text field, this is our text field. How do we get that? That text field is in here, right here. This is the whole text field that we want the model to see and to learn to do the fine-tuning. So this is like one example. This is another example. Oops, need to run this. Okay, and then we can see another example. So context, again, context, question, where is my question, and then answer. This format will go for your inference as well. Let me show you a little bit early. This is my inference, and the context, the question, and the answers. So you need to get the model to like into one consistent form to inform the model this is what you want during the fine-tuning. All right, assuming we have a clean and clear data set, let's get into the fine-tuning. Like I mentioned earlier, 80% of our job is to do the pre-processing and 20% is to do the fine-tuning. Pre-processing, again, is so important just to make sure that the model know what format to learn from and what format to adjust the parameters. And then now this is the 20%. It is 20% because it is basically a configuration where you can adjust, you can tune, it's tunable parameters. Right, let's get into it. So first we have a data collector. We have MLM is equal to false just because this is not a mask language. All right, and then we wrap everything with UnslothTrainer, where we have a model is llama model. We have tokenizer is a tokenizer from Unsloth as well. We need to let the fine-tuning know where's the trend data set, which is our SQuAD process trend. What is the text field for it to look at? This is important. This is the text field we want it to look at. However, we wanted to form it into a format like this, where in the end we have end of text, or else again your model will go on and on and on. So that's where we have formatting function is equal to formatting function. Max sequence length how long do you want your input should be. And then data collector, this is the arguments. For training arguments is tunable, is adjusted. You can try different numbers and see which one works for you. Per device train batch size 2 per GPU if you have GPU. Gradient accumulation step. How many steps to accumulate the gradient before adjusting the weight? Warm-up ratio 0.1 before updating the learning rate. Number of train epochs 3. This can be 3 to 5. Don't be too much because it's not really improve as much when you hit 5 epochs according to what I'm seeing from setting this number. Learning rate, embedding learning rate. There's a little notes here. Embedding learning rate, it had to be smaller than learning rate just to make sure that the continual pre-training work. So make sure this one is lower than this one. And then these two, basically, should we use 16-bit floating point if we don't have bfloat 16 supported? If we have bfloat 16 supported, then use this. Locking step. Do we want to lock every step? We do. This is an optimizer. If you are using deep learning, training a deep learning, you'll be familiar with this optimizer. In this case, we use Adam 8-bit just to reduce the memory. Weight decay, this is the hard regularization. Do we want this? In this case, 0. This cosine scheduler is to adjust the learning rate over time. Seed, to make the model more stable and reducibility. Output directory is this output. Do we want to report to anything? For example, like airflow? Maybe no, none. All right. And then trainer.train, it is looking like this. And it's running pretty fast. I run these 3 epochs for 30 minutes, which is quite impressive in my opinion. Right, that is the fine tuning. Yo, we're almost there. It's not that hard, right? I think the intimidating part is the pre-processing. Like, how do you want to do a data prep? How do you make sure that data prep, when you input into this format, this configuration, it work and it run? And then other than that, all the trainable parameter, you can try different number that make sure it work. And then that's it. This is, in my opinion, an easy part. With the template, you can just go ahead and pick and choose different number and change. But this part is where, how do we want to make sure this defined formatting function work? How do we want to do pre-processing function? How do we know that this type of format works and the other type of format doesn't work? So you have to go and change and then, adjusting accordingly before we get to the inference. All right, so now we have a fine-tuned model. Let's run the model on the inference. This is my inference. Again, I have to follow the format that you train the model. So you train the model to see the context, a question, and the answers. Now, when you do the inference, you also wanted to let the model see the context, the question, but not the answer. Because this is where we get the answer and we evaluate if the answer is correct, right? So, this format is the input. Wrap it up with a tokenizer. Why? Because model cannot read the text directly. It have to go through the tokenizer, make it into a list of integer where model can understand. And then this one, how long do you want the answer should be. If you expect to have like long answers, short answers, for me, this part 25 tokens seems working. So you've got to like try to tune this number as well. Then this is a pre-processing just to get to a nice answers. So my question is, this is the context, blah, 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 blah. The key here is known for his work on relativity. And then this is really doesn't matter. And then the question is, what is the theory that make Albert Einstein famous? The answer, he's known for his work on relativity. And this is the answer that the model gave me, which is correct. So far seems working. I've been trying on multiple different input, context, question, answer. It seems working with mass token 25 if you expect your answer to be very short. So this is again a tunable number. It's depending on how long, how short your question answers. But yeah, this is fine tuning. It seems again challenging. However, this is only the challenging part that I think once you get over this data pre-processing, knowing the format, knowing what you want, getting to the fine tuning, it's easy. Alrighty, let me know if you have any comment, feedback. Always love to have your feedback. Thank you.